there's usually a gap between the knowledge that the students would like to acquire in terms of space engineering, satellite engineering, and the availability in that. To get anything into space, it needs to be technology readiness qualified. They're usually levels 1 to 9, and something that has reached technology readiness of 9 is usually pretty expensive because it's been to space, and therefore the entry level for such equipment is usually $10,000 and above. We're looking at bridging that gap by introducing something that lowers the cost by a tenth. But that is a tenth of the actual cost of current existing solutions. And it's modeled on actual nanosatellites. Like it includes all the systems such as the onboard computer, the electrical power subsystem, the attitude determining and control that consists of sensors that are entirely fabricated and designed locally by us.
According to my research, the first artificial satellite sent into space was called Sputnik. Launched on the 4th of October, 1957 from the Soviet Union, it went into orbit around the Earth. It was designed to send radio signals back to Earth, which it did for 3 weeks before the 3 silver zinc batteries ran out. The success of this satellite allowed scientists to study the various layers of the atmosphere in more detail. Throughout the years, many satellites have been launched into space. In more recent times, many countries, including Nigeria, Kenya, and Ghana, have seen success in satellite launching. Bigger satellites are very expensive, so many of the latest satellite launches have been what is called CubeSats. They're about 10 centimeters on each side. This is known as one unit. In this small space, they have to fit cameras, wiring, computer processing, power source, and communications. There are a few ways they are put into orbit. One way is being jettisoned from the International Space Station. I caught up with a couple of scientists from Kenya working on just that.
My name is Gerald Mumbouth. Currently, I work as an intern at Omarit Space, which is a startup that is trying to revolutionize nanosatellite technology in Kenya.
My name is Vigil. My background is SERASpace engineering. A lot of information that we've learned has been in process learning. We're really glad that we're here now, that we're able to develop new solutions to problems that we face, climate change, agriculture, farming, education. Currently our focus is an EduSat kit that sort of solves the education component, where you have a lot of people, a lot of young aspiring engineers, but they do not have the training or the content necessary to be able to learn about satellites, to be able to learn about space systems, but they want and they're curious and they're hungry for this information. So what we're trying to do is develop an EduSat that's able to bring someone from the beginner level to an advanced level of understanding engineering, satellite engineering.
So what we have here is a nanosatellite development training kit. We've fabricated this one locally at Omarit's offices in Kenya. What it does basically is to allow a variety of trainees to learn about the internal systems of a typical nanosatellite, enable them to learn the intricacies surrounding its design and development, and to be able to get the hands-on capabilities of building their very own nanosatellite that can maybe be launched and be of service to their particular countries or for whatever reasons they deem fit.
Thank you for stopping by today. I look forward to seeing you next time. Who knows what we'll learn on the next rotation. Remember to learn something new every day.